Hey everyone, it's Mr. Bennett. This is section 8.4 of the energy chapter, and we're going to finish up with nuclear power. And these reactors, they're called nuclear reactors because there's a nuclear reaction that happens in order to generate some heat. And these reactors, they harness energy when atoms are split. So we can take atoms and break them down into smaller pieces, and that process, is called fission. Okay, fission is when we take a single atom, uranium-238, and we split it off. It breaks off naturally into two separate pieces. And when that happens, it releases some energy. That's a nuclear reaction because the actual substance itself, the chemistry of the atom itself is changed. This is what we control in our reactors, is we have a fission nuclear reactor. The opposite is when we combine atoms, or the opposite, combining atoms, is called fusion. And we cannot control these yet. And that's a big yet, because there are people working on fusion. And the problem with fusion is that it takes a lot of stuff, a lot of material, and it produces insanely high heat. So fusion happens in the universe. This happens in stars. So fusion, the sun is a big fusion reaction. So stars, S-T-A-R, there we go. And fission, again, is our reactors. That's what we do. But fusion reactions, these produce a lot more energy. It's clean energy. It's sustainable if you can get the reaction started. But the problem is that it creates a lot of heat, and we don't have a way to control that heat yet. So right now, we'll stick with our fission reactors. We have a diagram here of our nuclear fission reactor, and there's a few pieces of this reactor we have to label, and I'm going to do this in red just so it's a little bit easier to see. Here, we're going to start on the right-hand side. These bars here, these red and yellow bars, these are the uranium fuel rods. And this is the uranium. I didn't make this box big enough, so let's just jot it off to the side. This is uranium. And uranium, again, these bars are actually splitting those atoms. They're falling apart as we watch them, and that generates a lot of heat. Down here on the bottom, these black bars, these are called control rods. So these control rods can move up and down, so they can go up and down. And as they move up, they block some of that nuclear reaction. They block some of that decay. And it slows the reaction down. So these ones, they help control the nuclear reaction that's happening. We have steam being generated. This is very, very, very hot. So the water around it evaporates and creates steam, which runs off to the turbine, which spins a generator, which creates electricity, right? So we follow that same 6 steps. This is a giant pressure vessel, so there's a lot of pressure built up inside of here, and we pipe the steam off, it goes and does its thing, and then we actually recycle it. So this is cooling water. Cooling H2O. So this is cold water coming back in. It flows in, so the water is coming in that direction, flows up through the reactor, helps to cool it. Some of it is rotated or turned into steam, which then heads off to spin the turbine, to spin the generator. A nuclear reactor, when we're talking about conventional power plants or conventional power generation, nuclear reactor takes the place, let me scroll this down so we can see a little bit better, of a boiler, of a fuel, really, in a boiler. There's nothing being burnt. There is nothing being thrown into the atmosphere. It's all contained inside the nuclear reactor itself. So when you see the big smokestacks, quote-unquote smokestacks for a nuclear reactor, remember, those are the cooling towers. They help cool that extra water off. And so if you need to look back at notes number 2, this is 8.2 on power plant structure. So nuclear reactor would kind of just jump right in there. Once we have our steam, we can spin the turbine, spin the generator, all that stuff. There's some critical thinking questions here. Take a look at those, and if you have questions, you can always leave a comment, or you can ask me in class if I see you every day. Thanks for watching. We'll see you with the next one.